Before we get to solving absolute valued inequalities, let's first talk about a graphical method for solving quadratic inequalities. And that method is the same one that we'll use for absolute valued ones. And that method is considering this question, where is this function positive, to be the exact same question as where is that function above the x-axis. And that in turn is the same thing as asking what is the solution to x squared plus 2x minus 3 is greater than or equal to 0. Greater than or equal to 0, of course, means positive, and that means above the x-axis. We can see from the graph that there are two places where this function is above the x-axis. It's this branch and this branch. And the way that we express the solution set then for this inequation is we give the x values that correspond to this branch, that's these, expressed in this interval, and the x values that correspond to this branch, which is all of these numbers expressed by this interval, with the union symbol between them. So that's the same method we'll use to solve absolute valued inequalities. It's important to remember that by default, whenever interval notation such as this is being used, it is understood that we are talking about real numbers. In other words, this interval is all real numbers that are greater than or equal to 1, and this interval is all real numbers less than or equal to negative 3. Now, if you were looking for where the function is negative, then instead of looking where it is above, like we did here, we look for where the function is below. And once again, once we've identified the part of the curve that is below, we give our answer in terms of the x values for that part of the curve. Again, make sure you see that asking this question, solving this inequation, x squared plus 2x minus 3 less than or equal to 0, is equivalent to finding where this function is negative or below the x-axis. Notice also that this answer was just one interval, and the fancy schmancy way to write the whole answer would be x element of negative 3 till 1. Well, now that you've seen how that works for a quadratic function, now it's time to apply it to an absolute value function, and it's pretty much identical. If we had the function absolute x minus 1 minus 4, which looks like this, and we had to figure out where that function is negative, once again, that means where is the function under the x-axis. Our answer again is given in terms of the x values for the portion of the absolute value that is under, which is this guy right here. So the function starts being negative at the number negative 3, and it stops being negative at the number 5. So this is how we write our answer, and this is how the question would look. Where is the solution to x minus 1 minus 4 less than or equal to 0? If you had been asked to solve where is absolute x minus 1 minus 4 greater than or equal to 0, first just picture where the shading would be, which part of the graph are we looking at, above or below the x-axis. And if this makes sense to you, that these are where my two answers are, these two parts of the x-axis, then go ahead and write the full solution in x-element notation. If it doesn't make sense to you, ask me a question. This is your chance. I know you probably have to zoom in to see what the actual numbers are, but you can do that, right? It's VoiceThread, you can zoom in. Okay, so now here's how an inequation question is going to look. It's going to say solve the inequation x minus 1 minus 4 less than or equal to 0. And your instinct is probably to say, oh, I gotta bring the 4 over and I gotta solve it and do a bunch of algebra. No, fight that instinct. Instead, think this way. Think solving that equation is exactly the same thing as figuring out where this function, this guy right here in the graph, is negative, because that's what less than 0 means. And that is equivalent to asking where is it below the x-axis. And this function, of course, starts going below the x-axis at -3 and stops being below at +5. You try this one. Don't do algebra. Just look at the graph. So far, all the examples you've seen have had that or equals to in it. How would things be different if there was no or equals to? Well, you've probably already noticed that all that changes is that the brackets are exclusive instead of inclusive. As far as whether we look above or below, it's exactly the same. Less than 0 means look below. All right, you're on your own. Try this one out before you look at the next slide. So let's summarize things a little bit. When you're asked to solve an absolute valued inequality, you gotta know what to expect now. You might end up with a solution set that is one interval. In other words, x belongs to this one interval. Or you might end up with a solution set that is two intervals with a union symbol in between them. Now, are those the only two possibilities? I don't know, you tell me. What if we had to solve this inequation? Where is this function greater than 0? Yes, the answer is everywhere. And here's the way we say everywhere in math. X element of the domain, which in this case happens to be reals. So yes, there is a third possibility. My solution set might be the entire x-axis. So that's it, right? There's no other possibilities, right? But what if we were looking for the solution to this inequation? Where is x minus 2 absolute value plus 1 less than or equal to 0? Nowhere, that's where.
So yeah, here are the four possibilities. Now I want you to think about this. When does this happen? What kind of a situation, what kind of a inequality leads to there being one interval on the x-axis? I'll answer the first one for you. When we've got an absolute value that's opening upward and it crosses the x-axis somewhere and we're looking for where it's under, that's one situation that leads to a single interval on the x-axis. Is there any other situation would lead to that? Or can we always say, yeah, this is going to happen when it's a less than or less than or equal to, and then this other one's always going to happen and only going to happen when it's a greater than or greater than or equal to, etc., etc. Under what conditions do each of these things happen? Well, now it's time to crank it up a notch. What if you are asked to solve an equation and someone hasn't handed you the graph like what's happened for this voice thread? What do? Well, you sketch that puppy, and fortunately you're pretty good at doing that. So here's a sample for you. Here's an inequation. Solve this inequation, and don't do algebra, right? Fight that instinct. You're not doing this algebraically. You are going to do it graphically by starting with a sketch. So go ahead and sketch the function that's on the left-hand side of this inequality. Like I said, a sketch is good enough. All I really need you to put on your graph is where the vertex is and which way it opens, so that then you can decide where you're looking for the solution. Are you looking above the x-axis or below? Well, since it's less than, it's below. Which means that, as you can see, there are going to be two intervals on the x-axis in my solution set, and all we need to do is write out that whole interval without even doing any calculations. You can just write all of that out, and then all we have to fill in are those two numbers. What are those two numbers? Well, the first one is the first place where it crosses the x-axis, and the second one is the second place where it crosses the x-axis, otherwise known as the zeros. So now here's where the algebra kicks in, because we're looking for now the zeros of the function, which again, good thing you guys know how to do it, right? So now that we've got the two zeros, they go into the intervals. Make sure you put them in the right one though. The more negative one is going to go in the leftmost interval, and the more positive, well, the less negative one is going to go in the other one. So there you go, there's your solution set. Try this one. I would try it on paper. Don't try and sketch anything up here, but do the whole thing before you look at the next slide because the entire answer with all the steps is on the next slide. Good luck! Well, this is all fine, well, and good if it's a zero on the right-hand side of the inequation. What if it's not a zero on the right-hand side? Is that a big problem? Well, there's more than one way of handling this. First of all, you can easily get a zero on the right-hand side by simply subtracting 5 from both sides here, and you'd end up with solving the inequation absolute 2x minus 8 minus 2 less than or equal to 0, etc. Proceed as before. Graph this function and look for where it's under the x-axis. Or, instead of looking for where it's under the x-axis, you can look for where this original function is under the y equals 5 line. Up to you, I care not. Either way, don't do algebra, sketch the graph, look for where the graph is, in this case under the line, write out your interval, and then find the numbers that go in the missing interval places.